welcome to this last session of SUSE call. I hope it's been a good 4 days for you. In this session, we'll be covering about supply chain security for containerized landscape. My name is Rahul Krishna Gupta. You can call me Rahul. I work as a solution architect covering the APAC region. I'm based out of Mumbai and been with SUSE for a very long time, in my 21st year with SUSE. So today's session will be covering the supply chain security challenges, and as we try to address the challenges, we'll look at aspects like trusted container images, curated library of applications, and then also vulnerability and compliance scanning, and signature verification. So at every stage, starting from when the developer is building the application right down to when you're deploying the application in production, what are the supply chain security capabilities that SUSE brings to the table at each and every stage is what we are going to look into. Now, the typical challenges that we come across in a containerized landscape is developers tend to pull containers from multiple sources depending upon what they intend to use in terms of the runtime or the database or any other component that forms a part of the application. And it becomes difficult to track the container contents. Many organizations who are just at the startup stage probably are more focused on building the app and getting it to the market than thinking about security. But as you go into some of the regulated industries, these become very, very significant challenges. The ability to know what goes into your application, what exactly comprises your application becomes very critical, or sometimes even from an audit perspective. The container creation process also, you will see a lot of variance. It's not standardized. And then it's also hard to track the compliance as well as the vulnerabilities. And I have come across customers who tend to spend a very long time and a lot of effort in grabbing upstream images and then trying to build their own golden images out of them. A lot of effort is spent in trying to eliminate vulnerabilities. And the reality is that not all vulnerabilities can be addressed for various reasons, because for some of them patches don't exist. The result is they end up deploying applications with vulnerabilities in a production environment. And I have seen this happen with customers in the financial space, right? And only because they were not aware of what all capabilities they already have as part of the Rancher Prime subscription. Now, one of the other thing is, even if you have the best vulnerability management system in place and you have all the patches available, it's sometimes very difficult to patch once the thing is in production, because you may not get downtime, people may not allow you to touch those systems, and particularly if you are in financial industry, their approval timelines may vary from a few weeks to maybe even a couple of months. So while they are leveraging the containerized landscape, because of the policies that they have built over a period of time, they still cannot be agile enough to patch these vulnerabilities while in production. And supply chain security, we have come across many instances. One of the most famous ones was the SolarWinds, which was a target of massive cybersecurity attack. And basically, hackers managed to embed their malicious code into SolarWinds systems. And then as SolarWinds pushed out the updates to its customers, hackers practically found a backdoor into all those customers' systems, right? So this caused exposure of sensitive data on a large scale. Some of the other recent ones have been Log4Shell, kept the sysadmins awake for weeks trying to patch those systems. And you will still come across container instances that are impacted by Log4Shell vulnerability. And then the most recent one was XZ, right, which was right in the compression toolkit in the Linux kernel. So how can this sort of thing be prevented? The way is to eliminate your cloud-facing attack surface. Try to build a zero trust architecture where you have complete control at every stage of your supply chain. Try to utilize a certified Linux operating system which has the highest level of certification from a security perspective. And then run security audit and identify and stop advancement of known threats, as well as you can put in systems where you can protect yourself from unknown threats as well. But that's not going to be the focus today. We're focusing on supply chain security. So the foundation where you can start to implement supply chain security is right at the operating system layer. Whether you're using SUSE Linux Enterprise Server or SUSE Linux Micro, these provide a strong secure foundation for your entire software supply chain. And this has an impact in some of the container images also, as we'll see while we move along. So SUSE Linux Enterprise Server itself carries a whole bunch of certification, and some of them are really critical from a supply chain perspective. The most important one being common criteria, because that is not just certifying your software, it's actually certifying your entire supply chain, right from when the projects are incorporated into the distribution to the time when we deliver the distribution to the end customer. And then there's FIPS 140-3 compliance, which essentially are related to crypto libraries. This is also leveraged by our RKE to Kubernetes distribution. STIG, basically how to harden the system based on certain guidelines, and then for some regulated industries, PCI DSS as well. Right. SUSE Linux Micro inherits many of these certifications because it is essentially based on the same code base from which SLSA is built. So if you look at the common criteria EL4 plus certification, and this is a certification that other vendors do not carry on the x86 platform. SLSA is the only one that is certified for it. And as you can see, right from the time we pick up the community code and we do the code review, the entire chain is certified by under the EL4 plus certification, right? So as customers who are consuming SUSE Linux Enterprise Server or SUSE Linux Micro, you have complete assurance in terms of what is going into the product, right? And all these SUSE-based products, whether it is the core OS or the base container image, is created from the same code base, utilizing the build service that we have created over a period of time. Right? So starting with open source code, then reviewing the rigorous code review process, then careful selection of packages that go into the distribution, extensive testing at every stage. A lot of it is automated, and then there's also manual testing that can come into place. We have an automated build service. So from the same code base, we are building distributions for multiple architectures, whether it is x86 or ARM or System Z or Power. And then ensuring secure delivery of the software itself, and ultimately providing the ability to our customers to deploy a certified secure product on their systems. Right? So we're starting from the operating system layer. That's the first thing that you can think of in terms of securing your supply chain. And the next is the base container images. Now these are again trusted container images that are available from SUSE. So the SUSE base container images essentially are a set of images that are provided by SUSE that can serve as the base or as a foundation for building your own applications. So we have minimal images, which is just a very minimal base operating system on which you can deploy any application. We also have development images, which essentially are SUSE-based container images with a runtime like a Python, Go, .NET Core, OpenJDK, Rust, Node.js. You will find ready-made base container images with runtime environments built in. And then we also provide certain application containers like Postgres or MariaDB, some of these. Each of these base container images come with a full SBOM, come with full vulnerability information as to how many vulnerabilities they carry. And we continue to update these images at regular intervals. So the benefit is that customers, instead of trying to build and maintain their own golden images, can straight away pick up SUSE based container images and build their application on top of it. Now this has a very flexible licensing policy. These are free to use base container images. If you don't want support from SUSE, that is fine. You can simply download the images, build your own applications, and you also have the flexibility to redistribute those container images. So for our ISVs also, this becomes a very useful platform. And if you have a SUSE Linux Enterprise subscription, then you also get support for base container images along with the subscription. So if you go to registry.suse.com, this is the website. You can see you have the base container, the minimal ones. You have the redistributable base container images, right? Then the redistributable development container images and application container images. So you can also point your own private registry to mirror these images into your registry and then utilize them in your landscape. So if you look at it, the one thing that it is doing is saving you a lot of time and effort to build the golden images. The other thing is, if you build your application on a SLSA platform, which is already registered to SUSE Customer Center, then at the time of building your image, you can run a patch update as part of the image build process. So all the latest patches will also get applied at the time of image build. So as you can see in this example, we are pulling a minimal SLSA base container image based on 15.6, and then further down the process, we are essentially running some zipper commands. This is where if you are building the image on a SLSA system which is already registered, all the patches will get applied. So when you build the image, it will be patched with all the latest patches. Now you can of course control this. If you have, say, a multi-Linux manager set up within your environment and your host system is registered to that, then you can maintain the patch cycle using SUSE multi-Linux manager, and that way you can control what set of patches go into your images. But again, you can have full control and you have complete visibility into what's in the image. So this is starting with the base container images. Now, that's not enough to build your applications, because you might be leveraging a lot of components, things like Apache Kafka or Apis or some of the databases, Redis, Valkey. There's a whole bunch of upstream applications that may form a part of your own application that you're building. So through SUSE Application Collection, we are providing a curated library of secure, trusted, and compliant container images. And these are designed to give your teams peace of mind. Again, if you're downloading something from Bitnami or from Docker Hub or from Artifactory, and you look at the number of vulnerabilities that they carry, you will have to spend a lot of time and effort in trying to resolve them. And we are essentially pulling the same upstream images and rebasing them on the SUSE base container image and eliminating the vulnerabilities out of them. So basically, the application collection, if you have the SUSE Rancher Prime subscription, it is part of the Rancher Prime subscription, so you get access to application collection through it. What we are doing is enabling your teams with a single trusted and standardized way to install and use this public open source software. We are not providing you level 3 support on the third party software, but up to level 2 we are able to provide the support, and we always provide you patched, up to date, and very lightweight images. You will see that in certain cases the size of the image provided under application collection is much smaller than the size of image that you get from upstream, right? Again, this provides you guaranteed trustability and auditability, because you get complete SBOM, you get vulnerability scan reports from not one but 2 vulnerability scanners, and you have an antivirus scanned image as well. So you can maintain the supply chain security at the highest level. What you will find under application collection is set of applications, some of them available as Helm charts, some of them are available as single containers, and this is entirely depending upon what application it is. So the logos essentially give you an idea of which applications you will find, and the collection keeps on growing, and primarily based on the requests that we receive from our customers. So customers who are using upstream software and want them to be delivered through application collection can raise a request, and depending upon which one has the most demand, that would be prioritized to be included in application collection. Now, just the providing the images is not sufficient, right? There are a lot of integrations that need to be taken care of in the customer's environment. So if you look from a integration perspective, and these are all documented in application collection. So how to integrate with GitLab CI/CD, how to integrate with Rancher Manager itself, as in directly use application collection as a repository in your Rancher Manager or on your downstream clusters, completely documented. You can mirror application collection into your private registry if it is Harbor or JFrog or Sonatype Nexus, right? And because it is Harbor, obviously you will be able to mirror it into the SUSE private registry as well, because that's based on Harbor. And then all the images provided through application collection are signed using open source tool called cosign. So you can also verify the signatures using either cosign or KubeWarden, or if you are aware about SUSE security or NuVector, that also has a 6-store verifier built in. So application collection documents the process as to how you can configure the 6-store verifier within NuVector to verify that the images coming from application collection are signed, right? So signature verification also is an important aspect that we have incorporated here. All the images come signed to you. So we're talking about a secure supply chain, and we have set up a system wherein SUSE is able to release a new version of the image within hours of the upstream release. So if upstream a new version of, say, Apache Kafka comes in, we have set up an automated system wherein within hours of that release, you will have a corresponding version available within application collection. The one thing that we are doing here is, so all of these different applications are based on different base container images. Some of them are built on Alpine, some on Debian, some on older versions of Debian, and that is why a whole lot of vulnerabilities are built into these images. What we do as part of application collection is rebase all those software on a SUSE based container image. So I'll have a comparison between the same software coming from Bitnami and coming from application collection, and you'll see the differences that you see between them. So trusted sources, full software BOM, SLSA level 3 certification for all the images, and assigned and trusted artifacts. This is what you get from app collection. So I did a comparison of MariaDB, which is a very widely used database in the container world. And this is a comparison of MariaDB coming from Bitnami and from application collection. So as you can see, this is the Bitnami chart, and this was done sometime in mid-February. So you can see this is MariaDB version 11.4.4. That's built on Debian 12 R3. And you can see the number of vulnerabilities that it has, a total of 103. Right? Now, if the development teams pull down this image, or whoever is responsible for maintaining the golden images, they will have to worry about these 103 vulnerabilities, or at least the critical and high level ones, which are 6 in number. Right? The same thing, just a slight version difference we have from application collection. This is a screenshot from application collection. You can see the version is 11.4.5, right? And you can see right there at the bottom, no vulnerabilities detected. When I took the screenshot, it was scanned 12 hours ago. And you can see that we are providing SBOM in 2 formats. Cyclone DX, SPDX, we have scan done by both NuVector as well as by Trivi, right? And there is an antivirus scan done by ClamAV. So if you click on the System Packages tab, you will see a list of all the packages that comprises this MariaDB image. So this is just one example. You can compare any of the 72 odd packages that are available in application collection as of date, and you will find similar comparison between most of them. You will find these packages with near zero vulnerabilities in most cases. Right. So in summary, what are we doing? We are providing an up-to-date image of upstream software packages based on SUSE-based container images, right? So whenever new application, as soon as new application versions are available, only within a few hours you will find the release happening. And we are building a lot of images per day. You find you have complete visibility and control with automated reports detailing the origin and the history of every software component. We follow the best security practices, and that's how we are able to provide you images with near zero vulnerabilities, right? And these are optimized containers. You will find in certain examples that the size of the image also is significantly reduced. I'm forgetting the name of the image, but there was one very recently where the upstream image was about 180 MBs, and we brought it down to some 85 MBs or so. So a significant reduction in the image size. This is as of yesterday. I took these numbers last night from the application collection. As of now, 72 applications are available there, and this includes some of the AI modules, the Olama, OpenWeb UI, Milvus, and Olama, OpenWeb UI, Milvus, and what's the other one? MLflow. So those applications are also available here. Total number of vulnerability scans that application collection has done till date, 188,000, right? And total artifacts that exist in application collection is 49,500. This is a graph of the number of artifacts that application collection builds. And you can see on Feb 19, within a single day, there were 1,020 artifacts that were built. And this is all available to whoever has the Rancher Prime subscription. So this is an entitlement as part of it. So we have seen the underlying operating system. We have seen the base container images, and then we've seen the application images that you can get from application collection. So you can get a pretty much a very good grip on what's going into your application. And if something is not available within application collection, you can definitely raise a request for that. The next step is, once you have built these images, these are not going to remain static because vulnerabilities keep coming, right? So once the image has been built and pushed into the registry, you need to be aware about any new vulnerability that might be impacting your application, because then you need to plan for remediating that as part of your pipeline, your build pipeline. So how do you do that? This is where SUSE security comes into play, right? SUSE security, apart from everything else, provides you vulnerability and compliance scan, again at every stage of your build pipeline. So when a developer is writing code and committing code in your pipeline and a build is triggered, SUSE security can be integrated with your CI/CD tool. So whether it is Jenkins, Bamboo, Circle CI, Azure DevOps, a whole lot of CI/CD tools are supported. For some of them, there is a ready-made plugin available. For others, there can be an API integration. But you can essentially call SUSE security to do a scan at the time of building the image. And you can define the criteria based on which an image build can be passed or failed. So you can say that if an image has 3 or more critical vulnerabilities, then the build should be designated as failed. It should not be allowed to go further. NuVector will do that once you set that criteria, right? So right at the build time, you can integrate SUSE security into your CI/CD tool. And then once the image has been built and pushed into the registry, the image might be staying in registry for few days, few weeks, few months, depending upon how the customer operates. And vulnerabilities keep coming. So you need to be alerted on which new vulnerability is impacting the image residing in the registry. How do you do that? You configure SUSE security to scan your registry, right? And how frequently should the registry be scanned? Well, by default, whenever the SUSE security database gets updated, it will automatically scan everything that it is supposed to scan, including the registries that you might have configured. So here you can see a few examples. There is the set of images from Docker Hub. There is a set of images from there is JFrog images, and then NVDemo set of images. So you don't have to scan the entire registry. You can put in filters and scan a specific set of images or a specific portion of the registry. Once you configure them, SUSE security will continue scanning it. Anytime a new vulnerability is detected, and it is detected that the particular image is impacted by it, you will be alerted. And then you can kick on your remediation through the pipeline. And when we are scanning the image in the registry, we can do a layered scan. So at each layer within the image, a container image is typically built of layers. So at each layer, you can pinpoint how many vulnerabilities exist. So for example, in this particular CCI demo Docker image, you can see that this particular layer has all the vulnerabilities, 4 critical and 2 high-level vulnerabilities, right? So you know that whatever is being done at this layer needs to be looked into for fixing the vulnerabilities, right? And so you have built the image, you have image residing in the registry, and you're continuously scanning the registry. That's all great. But again, you have another gatekeeper that can be brought into play before anything goes onto your production cluster, production or whatever cluster it is. Before anything is deployed on the cluster, you still have an admission control mechanism, right? So suppose your image in the registry is now impacted by new critical vulnerabilities, and you haven't had the time to fix them. But if you are putting a rule in admission control saying that an image with more than X number of critical vulnerabilities shouldn't be allowed to be deployed, you can add that admission control rule again using SUSE security, and then SUSE security will block the deployment of that image and alert you why it was blocked. And this is just one example based on CVEs. You can have examples based on say namespace. You may have a policy that nothing should be deployed in the default namespace. Every application should run in its own namespace. You can put in a rule that nothing is deployed in default namespace. And as soon as somebody tries to do that, admission controller will block that deployment. There are 31 different parameters on which you can set admission control rules. So this is a very simple UI that you will come across. You can, this is a drop-down list of 31 parameters, and you have the ability to create your own custom parameter. So simple ones, like as you can see, image registry. So if you set up a secure supply chain, and if you have put in a policy that images should only come from your own private registry, you set an admission control rule here. Anybody tries to pull anything outside of your private registry, admission controller will block the deployment. Or you can say that unless SUSE security has scanned the image, it should not be allowed to deploy. So if this image has not been scanned by SUSE security, admission controller can block the deployment. You can set resource limit based rules. For example, any pod trying to ask for more than X amount of CPU or X or Y amount of RAM, you don't want that to be deployed, you can set up the controls. Or images that may provide root privileges or privilege escalations, you can block them. So there, as I said, you have 31 different types of parameters, and you can combine multiple parameters to create a fairly sophisticated rule as well. One of the simple ones that we showcase is a CV based rule where we define the CV is related to log4 shell, and then if you're trying to deploy a image impacted by those CVs, NuVector will simply, or SUSE security will simply block the deployment. And then the default namespace is very easy to demonstrate as well. Right? So admission control becomes another layer as part of your secure supply chain. And then not to forget the signature verification. You're signing the images. So if as an organization you set a policy that any image that goes onto the production cluster has to be signed by the signing authority, then you also need to set up a verification process that the image has actually been signed before anybody is trying to deploy it. So you can use various different tools. Cosign is one of them, for which we have a SIG-Store signature verification component built in. So what you can do is with SIG-Store verification, you can ensure that image signing and image verification, both capabilities are available to you. And what do you do after image verification? You have to take some action, right? So if the image cannot be verified, if the image is not signed, you can use the admission control rules to block the deployment, or if it is signed, then you can allow the deployment. That enhances your security posture. So every such small thing, right, each and every stage, if you combine all of them together, you will see that your security posture is significantly increased. And this actually does not involve too much of effort. This is actually helping you reduce the effort that organizations otherwise have to put into build this whole secure supply chain, right? So this is again a screenshot from SUSE security. The branding still says NuVector, but as you can see on the left hand side under assets, you have SIG-Store verifiers, right? Even if you don't have your own signature signing mechanism set up, the one that you can use to test is the SUSE application collection, because there we are already signing the images using cosign. Application collection provides a public key that you can configure here. So once the public key is configured, you can set up the SIG-Store to verify images coming from application collection. And then you can set an admission control rule that says that, so this is a registry being configured. You can see the apps.rancher.io, right? So we are configuring the registry under registries. After we have configured the registries, we set up the image control, the admission control rule, which says that image SIG-Store verifiers does not contain any of public. So this is the criteria, right? And basically it is saying that if the image is not signed by application collection, then deny the deployment of images. Okay. So how does this work, right? So here's an example with a very simple Nginx application that is available upstream, that is also available as part of the application collection. So once you have configured your SIG-Store verifier, once you have this admission control rule set up, then you try to deploy Nginx. The first one tries to deploy an unsigned Nginx image, just pulling it from upstream. So if I just say Nginx, it's going to try and pull it from Docker Hub. That's obviously not signed, so immediately it gives a message that creation of Kubernetes pod is denied because the admission control webhook comes into play because it's an unsigned image. The same thing I try to deploy using application collection. So now you can see that the Nginx version is coming from apps.rancher.io, and because this is a signed image and it passes the admission control rule, immediately the Nginx pod is created. So this is a very simple manifestation of how the signature verification can be implemented to ensure that only the signed and approved images go onto your production cluster. Right? So if yes. In the second, apply. What is that overriding? Okay, so what? This override. That is just the image pull secrets, because it's an authenticated repository, so it's going to use a secret to be able to pull. Yes. So that's only for pulling the image. So if you look at all the components that we covered during the session, you have the base operating system right there. You have the RKE2 or K3s Kubernetes engine. If you're using RKE2, that's FIPS compliant Kubernetes engine, hardened. And you can also deploy RKE2 with CIS profile defined at the time of deployment. So if you go into the Rancher dashboard and you try to deploy RKE2, you have a drop down where you can select that you want to deploy RKE2 with in compliance with CIS 1.3, or I'm not remembering whatever the latest version is. So you can deploy RKE2 in compliance with CIS benchmarks, right? And then we talked about the base container image, the application collection, and SUSE security. All of these components are available to you if you are having the SUSE Rancher Prime or the SUSE Rancher Suite subscription, right? Yeah, before we go there. So key benefits of adopting the supply chain security aspects that we provide: it definitely reduces your risks, minimizes the risk of security breaches, because if you are deploying something with near zero vulnerabilities, your security footprint has reduced significantly. You don't have to worry about taking care of all the vulnerabilities. You have improved compliance. I know of customers who run these applications directly pulled from the net. They have to actually go to their board to get an approval that their applications are running with vulnerabilities. Once you have base container images or images coming from application collection, that is going to significantly reduce. That's going to significantly improve compliance within the organization, as well as if any external compliance is required. I am not saying eliminate, but significantly reduce. And that reduces a lot of effort, because a lot of the effort is going into these non-productive requirements that organizations have to meet, right? It definitely builds trust in the software development and deployment process. You are able to quickly identify and remediate the security issues. As I said, if you are continuously monitoring what new vulnerabilities are impacting you, you can proactively fix those issues before anything goes into production. And overall, it definitely enhances your security posture, because you are eliminating vulnerabilities. You are building mechanisms that assure that everything that touches your production system has gone through a very rigorous process, and you know exactly what's going into those production systems, right? So all of the components that we talked about are part of the SUSE Rancher suite, and except for SUSE security, which is part of the SUSE Rancher suite, but add-on subscription for SUSE Rancher Prime, everything else is available to you as part of the SUSE Rancher Prime as well. Right? So the OS is there, the Kubernetes is there, and then application collection is part of it. Base container images are free to use if you don't want support on it. So all of this is already available to a Rancher Prime customer. You just have to start using it, start leveraging the benefits of what we already provide. Yeah, with that, I will end my session. If there are questions, happy to answer. Thank you.